Make start. You want to wait a couple of minutes?
I'm ready.
You ready?
Yep.
Okay, so today we have, it's Russell, right?
Yes.
And so it's CA1, so you present for roughly 30, 40 minutes.
Sure.
Is that right? Then afterwards we have questions with the panel and the audience. So in the room we have me, I'm Brian, I'm the chair. We have Fred as the assessor. We have some supervisors, we've got Dico, and we have CT, is the other one. Yep. Cool. I think that's all I have to say, so over to you.
Hi, thank you. First of all, welcome everyone for my CA1. My name is Resul Dalgano. My principal supervisor is Dicayu, and my co-supervisor is Sitilin. And today I will present my latest one-year research work of my thesis title of Improving Trustworthiness of Human-Robot Collaboration in Safety-Critical Scenarios. Initially, I will discuss about the motivation while we are doing this work. Second, we will go through the literature review. Third, we'll discuss about my research questions. And then we will discuss about potential methodologies to address these questions. And then we'll discuss about my latest one-year research work. And then finally, the future work, future plan, with a summary of this presentation today. So section 1 is motivation and definition, problem definition. So you can see that our title is Trustworthiness of Human-Robot Collaboration. So it includes the word trust. So let's define the word trust. Trust can be defined as an attitude that an agent will help to achieve individual goals in situations characterized by uncertainty and vulnerability. So the keywords here actually are the individual goals and the vulnerability and uncertainty of the environment. And there is certain problems related to this trust. For example, lack of trust. What do I mean by that is lack of trust towards the machine. For example, autopilot, the plane autopilot. The pilot can engage or stop the autopilot if pilot is feeling a lack of trust towards the system. And in a robotic case scenarios, we think that the future lies when the robotic system knows the value of trust a human gives towards the robotic system and acts upon that value. And this observation, this research direction comes from the observation of human relationships we do all together. We develop these interactions with humans because of the trust, and we always consider this value unintentionally. So, what's robot trustworthiness? In the literature, it's stated that human trust is history dependent. So, what's a history? History of interaction with a robotic system. And this graph shows very interesting plots. For example, when trustworthiness of a robot increases, but there is a lack of usage of robot, then there is a under-trust, or opposite is over-trust region. But the expected one is actually when the trust is calibrated, also called in the literature, or proper trust region, where the human is not placing a lot of trust, or over-trust, or human is not placing a lack of trust in the system, where we want the human-robot collaboration much more effective. And in the literature it's stated that human, robots, agent-to-agent, or interpersonal trust are all different. They have different dynamics. So we defined our motivation. Now let's discuss about the literature review. Trust is defined in two categories. So first one is trust dynamics between humans, which includes social impacts, psychological impacts, or empathy effects as well. And it is really hard to model trust between humans. But there is also research that we are particularly interested in, is trust of a human being towards a machine. So, which does not include empathy towards a machine. And this research about human trust towards a machine is mostly capability-oriented trust of a human towards a machine. And machines are used for specific projects, unlike human-human trust relationships. And finally, as I said, it is relatively easier to design and simulate a machine autonomous system compared to human behavior. And we discussed about the trust. So the question actually is, what are the factors that affecting the trust? In the literature, the researchers stated that there is three categories, there are three main factors that are affecting trust. First one is human-related factors. Basically, these ones are taken from the trust towards automation. So there is a human-related factor such as age, gender, ethnicity, or like fatigue or stress of a human being, or also like satisfaction and comfort exerting on a human being. And also there is a partner-related factors, which in our case is robotic system. And there is lastly the third category, which is independent of the human, independent of the robot. It is environment-related factors. There is also another category or indicators of measurements, which is a human behavioral analysis. Or, well, in our research, we categorize this left-hand side as a lagging indicators, which is a little bit time delay. But on the right-hand side, it is a lead indicators, which are dynamic, current moments, and it's much more harder. For example, analyzing the facial features, or analyzing the dynamics of the environment of human motions. And as I said, these are really challenging ones, relatively to compared to the self-report measurements. Also, this human analysis includes less bias and less human errors compared to the self-report measurements, because self-report measurements could be manipulated. Also, there is a time delay. And by literature review, we are now starting to formulate our research question. And the first research question is modeling human trust. And in the literature, it is stated that performance of the interaction or performance of the robots is really dominating factor. And this graph shows that this is a trust. The y-axis shows the trust. X-axis robot usage or number of interactions, we can say. And you can see that the human trust towards the machine increases. But if there is a certain performance drop or like a failure, like or incident, then the human's trust are suddenly dropped. And then, which states that it is really hard to regain the trust, and also it's really easy to lose the trust. You can see that it took a lot of interactions to build up the trust until this level, but little small incidents, relatively bigger one probably, but reducing a lot of trust reduction. And then what is performance is actually a competence, ability, or we can say the reliability of the robotic system. And performance in a literature state is a dominating factor that's affecting the human trust towards the robotic system. That is our some of the main motivations to go through the performance-based trust. So we discussed about trust modeling. We have the value of trust. We estimate that. And then what do we do with this? We observe humans. They unintentionally behave in a trustworthy to build up trust or reduce trust. So again, the question arises how a robotic system could make its decision makings based upon trust, or in a literature it's called trust-aware decision making. And this example really interestingly shows that there's 3 case scenarios, and then the highest performance is exerted when the robot picks up this glass and then puts in here. But because if human exerts lack of trust, it's a good idea to not start directly with the highest performance activity, but slowly build up the trust. And we want to extend this literature into a continuous performance value, because in this latest work, researchers did only binary case of successful failure interactions, but for a long horizon task, it's much more continuous performance. And then second question is how trust is changing dynamically in a multi-agent, multi-human environments. Because we know that in a general cases, we can have multiple robots working together with multiple humans. And then direct question arises like how this trust dynamics change according to the multiple humans and multiple robots working together.